Docker is a tool for running applications in an isolated environment. It gives you advantages similar to running your application inside a virtual machine. Some of those advantages are your app always runs in exactly the same environment, so you don't get inconsistencies in how it behaves. If it works on your computer, it works on every computer, it works on the live server, it always acts the same. If you're working on multiple projects, it lets you sandbox each one and keep them separate, good for security and eliminates potential conflicts between different projects. And lastly, it makes it easier to get going with somebody else's project. You don't have to install all of the tools and dependencies that the project needs. You just spin up the virtual machine, put your code inside, and it works. Docker gives you these advantages, but without the overhead and hassle of running and managing a virtual machine. Instead, we have containers. The code and the environment are all wrapped up inside a container, but a container is not a full virtual machine. When you run a virtual machine, each machine gets its own full operating system, including the kernel. The kernel is like the core of the operating system, the bit that controls the low-level stuff. And this is quite resource heavy on the host machine, the computer running the virtual machines. Containers, however, they all use the host machine's kernel. That core bit of the operating system is shared. But everything on top of that is still separated, everything that makes a Linux distribution unique. Because all Linux distributions, Ubuntu, Debian, etc. are all built on the same kernel. And Docker uses special features of the Unix file system to create these isolated environments. So a container is a compromise. The separation and sandboxing is not quite as extreme, but it's enough, and as a result, a container can start up in seconds as opposed to minutes. They use fewer resources too, taking up less disk space and using less memory. So a container is a running instance of an image. An image is a template for creating the environment you want. It's a snapshot of the system at a particular time. So it's got the operating system, the software, the application code, all bundled up in a file. And images are defined using a Dockerfile. A Dockerfile is just a text file with a list of steps to perform to create that image. For example, you'd configure the operating system, install the software you need, copy the project's files into the right places, etc. So you write a Dockerfile, then you build that and you get an image which you can then run to get containers. So let's try out this whole process. First, you're going to want to install Docker for Mac or for Windows. Links are in the description. This is just some software to allow Docker containers to run on your computer. And unless you've got a specific reason to use it, ignore Docker Toolbox. That's the older way to run Docker on a Mac or PC. I've created a new folder just on my desktop for this demonstration. And I'm going to write a super simple Hello World application in PHP. It's literally just going to echo Hello World. And I'm going to save that in a folder called src for source as index.php. Right now you can't execute that file, you need a web server. Our goal is to use Docker to create one. So let's make a new file and we're going to call this Dockerfile. We're going to save it next to the source folder, not inside. Dockerfile, capital D, one word. And in here we're going to use code to configure our environment. So for this we want an operating system with PHP and Apache installed. Apache is the web server software. The cool thing though is we don't have to start from scratch. We start in our Dockerfile with the name of an existing image, an image that has already been built. And then we build on top of that. Conveniently, you can find lots of existing images on the Docker Hub. So if you go to hub.docker.com, sign up, the search doesn't seem to work if you're logged out. You can search for images, so we can search for a PHP image. Now the hub includes images from the whole community, so it's up to you to decide if the image is suitable and well maintained. The best ones to look out for are the official ones. Luckily for us, an official PHP image already exists. At the top you'll find all of the variations of the image. These are called tags. So we just want like the latest version of PHP and we want Apache as well. So this line right here, this has a few versions of PHP with Apache. Going left to right they get less specific, so this will give you specifically 7.0.10. All the way to the end where this will always just give you the latest version of PHP. That one's usually a bad idea though, because that means PHP could just unexpectedly be upgraded and it might break your old code. But one of these other ones is fine for us. Now if you scroll down, you even get instructions telling you how to use the image. If you find the Apache section, it tells you what to put in the Dockerfile. So we first want to define the base image using the from keyword. And we want the name of the image, PHP, then a colon and the name of the tag. So we'll use, as suggested, 7.0-Apache. And then we want to copy our files inside the image using the copy keyword. So we want to copy the contents of source into /var/www/html. They're just telling us here that this is where Apache will look on its own file system and to find the files, so we should put our files there. And you can see now why I called that folder source, just so it matches these instructions. We want one more thing in our Dockerfile. We want to use the expose keyword to expose port 80. This just means when you run the image and you get a container, that container will listen on port 80. By default, it would just ignore all incoming requests. If you're wondering what operating system this PHP image is based on, you can usually find the Docker file that it's defined by. In this case, it's linked next to the tag names. And we see it's based on Debian. Similarly, that Debian image will have its own Docker file and they'll stack on top of each other like I said earlier. And this layering of images is a huge advantage of using Docker. The PHP's Docker file is a little bit more complicated than ours, but let's just focus on ours for now. So when we build our Docker file, Docker is going to download PHP from the Docker Hub. It's going to copy our files from source to this location inside of the image. It's going to tell running containers to listen on port 80. And then it's going to output a new image, our new customized version, which we'll be able to run. So to build it, I'm going to go to a terminal. First, I'm going to move to the folder that it's in. So we can see we've got Dockerfile right there. And I'm going to type docker build -t to give it a name. I'm just going to call it hello world. And then at the end, you want to tell it the location of the Docker file. Now, since it's in the current directory, we just want to put a dot to say that. Oops, helps if I save the Docker file first. The first time you do this, it'll have to download all of the layers that make up that PHP image. Shouldn't take too long. Once it's got the image, it's going to copy our files inside. At the end, it outputs our new image, and it's going to be called hello world. So we can run this by typing docker run hello world. There's one other thing we need in the middle of this. We need to use the -p tag to forward a port 80 from the host to port 80 in the container. So that means when a request gets to the host is your computer. When a request gets there, Docker's going to forward that to the container. And when it gets to the container, that expose line that we've got in the Docker file, that will let the container accept the request and allow Apache to handle it. So we can run that, we'll get some output from the container, from PHP, and then we can go to localhost and we'll see hello world. So we've done it, we've got our application running inside a Docker container. Now, if you go back to index.php and you change this, when you refresh localhost, it won't change. The Docker container won't reflect the new version of the file. And this is because when we built the image, it made a copy of that file. To see the change, you'd need to rebuild the image and spin up a new container from the updated image. During development, this is obviously a massive pain, and this is where volumes come in. So there are two types of volumes. One to persist and share data between containers. We only have one container. I'm not going to talk about this today. But the second type lets you share folders between the host and the container. You can mount a local directory on your computer as a volume inside the container. Then the container, when it's running, will be able to see the files that we're working on. Hit Ctrl-C to stop this container. To mount a volume, we're going to add another option to the Docker run command. We're going to add -v, and we want to tell it to mount the folder users/j/desktop. It needs to be the full path, not a relative one. /docker /src. So we want that folder, that local folder, to be mounted, so we put a colon, inside the container at /var/www/html. So the image, it copies this folder to this location inside the container, but during development, we don't just want to copy, we want to see that folder. We want a live view of that folder so we can mount it at that directory. So this time when you run it, you'll see changes that we make are reflected straight away. As soon as we refresh, the Docker container can see that change in the file because it's looking at the file itself. So this is really useful during development, but before you deploy this and try to run the image somewhere else, you will need to rebuild the image to get an updated copy of the files put inside. Volumes just give a running container the ability to see files on the host machine's file system. They do not change the image. So when you're done, you can press Ctrl+C to stop the container again. So one last thing I want to mention. You can see we can easily stop a container manually by pressing Ctrl+C, but containers will stop by themselves when the main process exits. In this case, that would only be if PHP died for some unexpected reason, but you can equally make containers with short running tasks. You might have a container which runs tests or a container which runs composer install. The process running in these containers will end when the task is complete, and when that main process ends, the container will stop. So for this reason, you should endeavour to have one process per container, because the life of that container is tied directly to a single process. So you don't want 5 other things going on in the background that will all be brought down without warning when the main process terminates and the container just stops. But since containers are really lightweight, you can run loads and loads of containers on your computer all at the same time, and it's no problem at all. So we found a suitable image to use as a base image on the Docker hub. We wrote a Dockerfile to augment that image, and then we built that to output our new customized image, which we could then run to get a container which would run our application. We mounted a volume using the -v tag, and we ended up with a Docker container running. Granted, it's a very simple application, but it is that easy. 3-line Dockerfile gets this up and running. In a future video, we'll look at more complex situations, and we'll look at orchestration options and deployment options, so you can get your container to run a website on the internet. Please let me know how you found this video. Feel free to ask any questions. I'll try to answer as many as possible, either in the comments or in a future video. Thanks for watching.